Welcome to APEC. It's January 15th, and I'm your moderator, Tim Ventura. First, I'd like to thank everyone for joining us on this call, along with everyone watching us on YouTube. In today's session, Detlef Hoyer will present a hypothesis on the physics of the Hutchison effect. Kevin Day will talk about Navy UAP encounters and recent UAP expeditions. And Todd Desiato will discuss Alexey Chekurkov's Graviflyer. Mark Sokol is also going to be discussing his recent appearance at the Tesla Society, and we're going to be hosting a discussion on Alzofon experiments. We're going to finish off the event also with an open discussion and ad hoc presentations by conference attendees. So let me do some quick reminders. You can view conference replays, details, and speaker info on our website at altpropulsion.com. Please save those questions for the Q&A session after each presentation. You can raise your hand in Zoom using Option Y on Mac or Alt Y on Windows. Again, that's Option Y on Mac or Alt Y on Windows. You can also type those questions in the chat. We do our best to go through them after each presenter finishes. Okay, so let me now introduce our first guest. I'm very excited to have Dr. Detlef Hoyer return. He has a PhD in theoretical electrical engineering and a focus on research in classical 5D Kaluza relativity theory. He'll be discussing key elements of the Hutchison effect and propose a possible explanation for it based on his work in higher dimensional physics, such as Kaluza-Klein theory. His focus is going to be on the levitation aspect of the effect, not on the materials disruption. So with no further ado, let's welcome Detlef to today's event, and I will hand it over to him.
Hello, greetings to all attendees and viewers. In the preceding APEC conference, host Tim Ventura presented photos and videos showing effects of Hutchison's experiments. Hutchison usually sets a lot of electromagnetic equipment in operation. Also, the presentations about the Graviflyer and Tesla's resonant motor were based on electromagnetism and electrical engineering. As a physicist with graduation in theoretical electrical engineering, I today try to make a guess about possible physics behind the effect. As you may remember from my last presentation in summer of last year, actually I extended my research to 5D electromagnetism. So welcome to the presentation, Hutchison Effect Revisited. The background pictures shows the Guggenheim Museum in Bilbao in the north of Spain, symbolizing a ship anchored on the banks of the river Nervion. This is a short overview. It's the topics of the chapters, but of the sections. Yes, the first two is a look back on the last conference and a short introduction into Hutchison effect. And there's a problem with to have an explanation for the effect, and I compare it with the progress of maser and laser development. Then an interesting part of 5D Kaluza theory is the cosmological constant, and there are two, one in 4D space intrinsic and one in the fifth dimension, which is called extrinsic. And generally each physical value can be split in the 4D one and a 5D component. Then there are interesting effects in 5D electromagnetism. And there is a scalar field in Kaluza theory, which might have also quanta. And then we come to the conclusion. The Hutchison effect shows disruption of materials and levitation of objects produced by the so-called Hutchison effect. Between 2004 and 2008, Mr. Ventura made various trips to visit Hutchison for interviews to take macro photos of disrupted materials. The videos were made in 1980 by John Hutchison. These are the typical photos, the balcony of Hutchison's apartment and inside the apartment with all his equipment. This is a block circuit diagram of all the involved electrical components, Van graph, 15 kilovolt DC with a spark, and Tesla coils. It's a short review on the last section. I hope you hear. Did you hear the sound of the video?
Actually, Detlef, no, we do not. And the reason is when you share your screen, you have to specifically share sound. Is it okay to play that without sound? Or do you want to stop sharing and restart sharing? You may need a plugin for that as well.
Okay. Yes, I should have the
we can try if you'd like.
Yes. Yes.
Yeah, I would say go for it. If you want to stop sharing and restart sharing, there should be a little checkbox down at the bottom of your screen when you start sharing your screen, and it should say share sound for this.
Okay. So
what I can tell you about John's equipment is he has had 2 up to 3 Tesla coils going together simultaneously, not always, but sometimes. He has worked with Van de Graaff generators. He has also worked with naval broadcast equipment, right? Stuff that should never be fired up inside of a house. But so he's worked with a lot of different stuff. The Klystron is an additional piece. He would have to be the one who tell you how often he used all of those together. What I can tell you is, again, the piece to remember is his stuff is primarily electrostatic. There's very little, like he's not using a lot of magnetic coils. The closest he gets to a coil is like a Tesla coil, right? So it's primarily electrostatic, and it is in a building that is packed to the rim with metal. So whatever kind of field effect he's creating is incredibly complex because it's all re-radiating.
So when you say static, you're not saying he's applying direct current. It looked to me like he was using AC.
He's using both. He's using both. And if I remember right, I think the effect has happened most often when he's using like a Van de Graaff, which puts a DC bias on like the entire room, right? So you use a Van de Graaff, and then you use then he would use the Tesla coils also, you know. And he also had tunable. One of the things that they talked about was he had tunable knobs on some of the radio equipment, and he would say he would start to turn the dial and the effect would happen, you know. So one of the things that and the reason I mention that is Colonel John Alexander from SRI, and I think John was working with the CIA at that time too or something. They sent a team in the 1980s to investigate what was going on there. And they spent, if I remember right, about a week with them. And they saw the effect happen, if I remember right. That they wrote a report on it and said at the time, in fact, what did they call it? I think there was a story written about it called the poltergeist machine. They believed that it was some kind of a machine enhanced psychic power, if that makes sense. And what I had said to them was, I'd said, because I'd talked to John about this later, and I said, why did you pick that? Well, part of it was at the time SRI was getting paid to find psychic stuff, so everything they found became psychic, right? That was yeah, you know, that was part of it. That was, you know, they were the remote viewing guys, so they were psychic everything. But
The other part was I felt like I've known people who were hands-on, and like when John is turning those dials, he could, you know what I mean? He could feel, yeah, you know, and that's not just him, that's any machinist, right? My ex-wife, my first wife's father was a machinist. He could turn a dial and know when to stop turning it by hand.
Yeah.
And that's something that no PhD physicist is going to know. It's,
I know you got to do it. You got to actually do it.
yeah.
It's a failure thing. You know, you gotta fail over and over and over and over and over again, and then finally get it right. And then you have to repeat it. And it's the repeating part that's the most difficult. It's going back and getting it to do it again. Okay.
So thank you to both of you. I hope it's okay. I showed it again. Now, some of the pictures which were shown. This is the disrupted metal bar. Then liquid paint was levitating, and a cannonball sphere. So this is an example what was shown last time. And George Hathaway wrote a book about it and had several key points. He said it's painfully clear that there is no conventional physics theory that can explain the movements and fragmentation I personally witnessed. It is within the realm of possibility that I were duped during the witnessing of the phenomenon, but highly unlikely. It's also possible that many other earlier witnesses had been duped during his many early private demonstrations and experiments, but also highly unlikely. It is noteworthy that during our association with John, he had to be physically present for any activity to occur, even if we, Alex and myself, had set up the apparatus ourselves. Discussions and publications about anomalous mind-matter interactions became more commonplace in the scientific literature. Although nowadays John takes pains to play down the possible psychokinetic aspects, no one I am aware of can provide any other theory that explains the totality of the phenomena, assuming there's no fakery involved. It is tempting to try to make a strong correlation between John's mental state and the frequency of the activity. I have not investigated this aspect of the phenomenon in detail, but I would not completely discount the likelihood that there may be a small correspondence between, say, the failed major demonstrations and John's emotional life. The Hutchison apparatus has continually changed in both number and type of components, as well as the way they are interconnected. Over time, John would add or subtract various pieces of apparatus that he typically had made. This continual alteration to the devices is also one of the reasons that Hutchison effect is so difficult to scientifically investigate. Since there is no one single configuration, it could be argued that an almost arbitrary configuration might result in various, if not all, of the phenomena. The conclusion to which I am forced to admit is that there was, and still possibility, is a highly anomalous phenomenon associated with John Hutchison that conventional physics cannot yet address. Whether we will find the answer as a result of experimentation involving John and his apparatus is not known, but seems to diminish in the likelihood as time goes by. Einstein described, now I try to argue that it's not necessarily a psychokinetic effect because the development and understanding of such physical apparatus needs much time. And for the laser and maser development, Einstein describes stimulated emission as a reversal of absorption as early as 1916. That means that when a photon arrives at an atom and another photon is emitted, then the other photon takes the same direction as the incoming photon, and that was what Einstein published 1916. And now imagine an experimenter, let's say Nikola Tesla, was able to the same time to produce laser light, and he uses a flashlight, a fluorescent tube, and 2 mirrors. And how does he get it to work? In 1928, Rudolf Ladenburg succeeded in experimental proof of the stimulated emission itself. It was puzzled for a long time whether the effect could be used for the amplification of light, because for reaching the amplification, an occupation inversion has to occur. This is impossible in 2-level systems. At first, a 3-level system was considered, and the calculation showed stability radiation in the microwave range. 1953, the first maser was built by Charles Townes, James Gordon, and Herbert Zeiger at Columbia University. 1957, the first infrared laser, the infrared laser research began at Bell Labs. And 1960 in May, Theodore Maimer was able to demonstrate the first working laser, a ruby laser. That is what we saw here. A flashlight for the occupation inversion and a ruby crystal and 2 mirrors. That was in 1960. And also in December 1916, Ali Javan showed the first continuous infrared helium-neon gas laser. And in 1962, the helium-neon gas laser with the red light as we know it. And this development took 56 years. And this to get this helium-neon laser work, you need a thin glass tube of 1 millimeter diameter and several decimeter long. Gas consisting of a mixture of 10:1 of helium and neon, total pressure of about 1 torr, small electrical discharge of 1 to 30 milliamperes, and at 1 to 2 kilovolts. And to ignite this lamp, a voltage of 10 to 15 kilovolts is needed. 2 Brewster mirrors and windows, polarization windows, and 2 mirrors. So if it's not possible to get an explanation for the Hutchison effect, it does not mean it's psychokinetic. The lifting of massive objects could be based on the same force that drives UAPs. We saw this cannonball lifting. UAP propulsion is barely assumed to be psychokinetic based. So the focus on interaction between EM and gravity should be there, which is also mentioned several times in the book of Hathaway. So we need a short excursus to relativity theory, astronomy. General relativity says that mass and energy cause curvature in space-time. So a constant mass density as dust in the universe causes constant curvature. And a circle has constant curvature, and the first equation defines points x, y of a circle. And with 3 coordinates with this equation, we get the points of the surface of a sphere, which is 2D and the sphere of 3D. And with 4 coordinates with the same equation, we get a 4 sphere which has a surface which is 3D. So there's a 3D space which has constant curvature in all directions. And we can describe it mathematically. And this 3D space as a surface of the 4th sphere with the same intrinsic curvature everywhere, plus a time coordinate. And when the radius of this 4 sphere has a time dependence, and we now use 5 dimensions, then we get the Robertson-Walker model for the universe with the Big Bang, and that's the solution of the Einstein equations for the Robertson-Walker model. So here is a picture with the expanding universe from the Big Bang and getting bigger and bigger. There's on the upper left side the Robertson-Walker model equation of Einstein with the metric, and A of t represents the scale factor, the radius of the balloon. And this is the solution of the Einstein equation, which is written there. So if we have on Earth a body of 1 kilogram with a velocity of 11.2 kilometers, that's the escape velocity for Earth. So if this 1 kilogram starts with 6.3 10 exponent 7 joule, then this kilogram leaves the Earth and vanish in infinity and will stop there in infinity. So the point is the kinetic energy of this 1 kilogram is vanishing in the gravitational field. Energy or the energy of the gravitational field cannot be localized. And during this kilogram, even the Earth, stopping in infinity, loses the full kinetic energy, and it's dissipated into the gravitational field. These are points for the conclusion. This is point 2. Point 1 was focus should be put on interaction between EM and gravity. So behind this is also the conservation of energy. So while the kilogram climbs the gravitational potential, it loses kinetic energy and gets potential energy. And this is also true for all the points of the ball on the universe. So if the universe is expanding, on every point the gravitational potential is climbing up, and every moving particle or body loses kinetic energy. Sorry, I have to. These are two equations from the Friedman, they are called the Friedman equations from the Robertson-Walker model. And they have to be fulfilled and are some kind of energy conservation. The second equation says that the kinetic energy seen from the origin, which is the center of the ball of the balloon of the description of the universe, of a particle of unique mass moving with the expansion, plus its negative gravitational potential energy, also relative to the mass contained in the space of matter closer to the origin. It is equal to a constant relative to the, in other words, the energy relative to the origin of a co-moving particle in free fall is conserved. So it's, but it's for a point in the universe which is always on the same location. It's just moving orthogonal to it. So, but if we have a body which is moving in the expanding universe, there is a Hubble drag, which means that the body is slowed down. The Hubble drag force exists for motion with respect to the isotropic galactic free fall frame because the isotropy of the cosmological metric picks out a preferred frame. The energy and momentum lost by Hubble drag are dissipated into the gravitational field of the universe on cosmological timescales. So that's the Hubble drags. So there is if the gravitational potential is varying during the motion of the particle, there is a slowdown, or if the universe would also shrink, then there would be an acceleration and temperature would get higher instead of the microwave radiation, which is getting cooler and cooler during the expansion of the universe. Now, the gravitational potential of the universe has to do with the cosmological constant, which is written in this book here. And on the next slide, I have the equations again, and we take a look at them. On the left side again is the Robertson-Walker metric, but with an additional fifth dimension, minus dl squared. So here on the left side, there is the scale parameter, not a, but s squared. And it's in the literature sometimes s or a. And here in the book, it's taken L, which is the extrinsic, then is the intrinsic cosmological constant. And if scaling is done also with a small l, which is the intrinsic cosmological constant, then the point is that the 4D Einstein universe with reasonable properties of matter can be viewed as a 5D model on a hypersurface whose size is related to the cosmological constant. So the cosmological constant is analog to the radius of the universe. It can widen it or shrink it and change the gravitational potential everywhere on the same level. We know this from electromagnetism, that there is a Gauge freedom, and this is the Gauge freedom of gravitation. So with the cosmological constant, you can adjust the gravitational potential of the universe, and there's no force because the potential is always the same. There's no force. The gradient is 0, so it doesn't matter whether the potential is small or big, but you can scale it and scale the metric, whether it's a small universe or a big universe. But it is taken here as a hypersurface, which can be scaled inside of a 5D space. So on the left side, you see the equation, and this picture might show that below the body in 4D space, the gravitational potential can be made smaller in a region. So there may be forces around this gravitational potential with low level, force into this, and could make the pressure in the air higher around this person. Yes, and on the right hand, this shall be a 4D hypersurface in 5D, which has different levels of gravitational potential. And on point 5, the gravitational potential is sunken, the space is shrunken, and the temperature increases. The opposite is at point 8. There, the scale is bigger, the temperature lower, and the potential higher. The variation in the 5th dimension causes a new force in the green area. Yes, it's the Hubble drag. And also in the green area, perhaps by RF, a fluttering of space may cause a disruption of material, and perhaps also this 4D hypersurface can break here and be separated in different 4D membranes. And then the higher separated 4D brane in violet may be shoved above the lower separated 4 brane in red. So different bodies can share the same 4D space, also being on different levels in 5D. Or another possibility, a wobbling of the layer causes 2 layers of the space, but we will see it later again. So these 4D branes in relativity are described with 10 gravity potentials, G mu nu, which depend on the 3 space dimensions and 1 time dimension. They describe the space-time, symmetric, the curvature, and the time dilation. And because the tensor is symmetric, there are only 10 different potentials. On this metric tensor, an operation is done, which is the Einstein tensor G mu nu. and it has to be equal to the energy stress momentum tensor with proportional constant kappa. So this is the connection between curvature of spacetime and mass and energy. Here we see the different components of the energy stress momentum tensor. T00 is the time component, that is the mass density or the energy density. And on the diagonal is pressure causing curvature, and the orange is the energy flux or momentum flux. So and in 5D Kaluza theory, we have another dimension, L. It's called L. Again, the metric tensor is a matrix, and here with diagonal of 1, which is the Minkowski space of special relativity. And to this space, the electromagnetic potentials are added. The electric potential Phi for Coulomb, and the 3 magnetic vector components, vector potential for the magnetic field. And if we take the Einstein tensor of this metric, one gets immediately the electromagnetic stress energy momentum tensor of electromagnetism. So this is equivalent. The electromagnetic stress energy tensor is directly a curvature tensor of a 5D metric. It's can be shown mathematical or with computer algebra software, Maple or Mathematica. You can see it there. And yes, that's the Kaluza miracle. So, but we want a gravity equation. So the Einstein tensor has to be 0. And this means that the electromagnetic stress energy tensor has to be cancelled by the gravitational field. So we do not need special relativity matrix with 1 diagonals, but really gravitational field with all 16 components, which are 10 different potentials. So now we have 15 different potentials, 1 for the electric field, 3 for the magnetic field, and 1 is the proportional constant of the equation. So now this 5D equation is split into 4D parts and parts which contain 5 their quantity, which means they depend on the 5th dimension. And so on the left side, we have the Einstein equation in 4D. On the right side, the stress energy momentum tensor. And the first part is identical as we saw before to the electromagnetic stress energy tensor. But there is, and this is the Einstein-Maxwell equation, the general relativity equation for electromagnetic fields and charges. But here, from the 5th dimension, we have another stress energy tensor in 4D from the scalar field. And this is new. The first two equations just from the slide before. And there are two other equations which involve, again, five from the fifth dimension quantities, which is the third equation equal to the Maxwell equation, which follows also all from the Einstein tensor in 5D being 0. And there's a wave equation in 4D for the scalar field with electromagnetic fields as excitation. So this is point 10, and for the conclusion, electromagnetic fields may dispense energy to the scalar field, pumping energy into the room. And for this, the Tesla coil or DC sparks with 15 kilovolts can be a reason. So it's from my work, the solution of the field of a charge in 5D. It's the field of a mass like a black hole, and the Coulomb potential Q over R. And the equation should be, the equation shows that the calculation of in Maple shows that the Einstein tensor of this metric is 0. And now we have to put this into 4 dimensions, and this is in the lower right. This is the energy momentum tensor in 4D of this metric. And we see here the T00 component is 0. So there is no field energy. It's the same as with a gravity field in 4D. There are only diagonal elements, which means there's a pressure. And it's as with the field lines, there's a pull along the field lines and a push between different field lines. And it's both pressure elements. So the force, the electric force comes from pressure. And the field energy of the electric field is cancelled by the scalar field. But if we have a moving charge, then there's also energy. So an electromagnetic field, also electric field and magnetic field, have much energy in the field, not in the center of the mass. But where for a charge, or the charge is directly in the mass center, and the field has no energy. So we saw the electromagnetic energy momentum tensor, T mu, can be generated from 5D curvature. The electromagnetic field energy and scalar field cancel out. Electric force is caused by pressure, pull along field lines and push between field lines. The static field of a charge does not have any field energy, like gravity. Charge contributes directly to the mass at the center. Charge has only field energy when it moves and has an additional magnetic field. The gravity constant is stronger in the vicinity of the charge. And if we don't know that, it would look like a reduction of effective mass of the test particle because it's more accelerated than it should be. And that this gravity, the varying of the gravity constant, I have to go back. That is the, on the left upper matrix, write down the 1 plus q square over 2mr. That is the kappa, and that is different. It's a function, it's not a constant. So what can we imagine about this physics, about this math? If you have the electromagnetic potential with A with components AX, AY, AZ, we would paint this as this. Here's the 3 components and the resulting vector. But with 4 and 5 dimensions, there's difficulty. And it's possible to paint all the 4 components of space-time into an area, into a plane, and to have the 5th dimension orthogonal to it. And this would look so. We have a vector AL in 5 dimensions, and it has the components T, X, Y, Z on the plane, and orthogonally kappa. So this would be a possible view for the 5 dimensions. So we have a plane of 4D space, a 4D brane, and an orthogonal component in the 5th dimensional direction. So it's like a pile carpet, 4D brane in 5D space, or a fur pelt, or a skin with hair. And these 5-pot gives a pyramid, which could be a symbol for space travel, if this is the explanation for the forces we don't know. Could also be that we have 2 layers, a double layer, where 2 different bodies can move into another and share the same 4D location as we see wood and the metal, or the knife in the metal. And that is the region, the green region, where RF frequency may wobble make a wobbling of the 4D brane and generates a double layer. Maybe a possible explanation. So this is another solution in 5D. Without charge, there is in the upper right corner no component. But it means it's the Schwarzschild solution of a black hole when A is 1 and B is 0. And when A is 0 and B is 1, then it's a similar solution, but for other dimensions, and it's called Soliton. The parameter A and B have to fulfill this equation, which gives an ellipse. And AM is the gravitational mass, and BM is scalar mass, which could be an explanation for dark matter. And the total energy contained is A plus B over 2 mc squared. So this soliton has no mass at the center. The mass is surrounded around the center and seems to be of radiation. It's not particles, but radiation. If this soliton solution of the 5D field equation Einstein tensor is 0, is also to be a solution of the 4D Einstein equation, then matter must present with density and pressure given in the equation before in the solution. The equation of state of this matter is that of ultra-relativistic particles or massless quanta. Since the soliton lacks the off-diagonal terms typical of the 5D metric with electromagnetism and photons, it is reasonable to assume that the soliton field consists of gravitons and scalarons. However, the gravitational mass of the soliton, as calculated from usual definition, goes to 0 at the physical center of the geometry. And others call it the particle for the scalar field, not scalarons, but dilaton for multidimensional theories, or radion for the Kaluza-Klein theory. And it says in Wikipedia, in particle physics, the hypothetical dilaton particle is a particle of a scalar field that appears in series with extra dimensions. And the volume of the compactified dimension varies. That is the scaling, which I told with varying of the cosmological constant. Then the volume varies, and it says that would cause dilaton particles. Geometrically, the physical center of the soliton metric is typified by unbound values of the 5D and 4D invariants, while there's no gravitational mass located there at the center. The center is the singularity from which gravitational and scalar forces, scalar fields diverge. It was further confirmed by Sokol and Wesson, who used a Hamiltonian method to calculate the metric-based energy of electrical charged solitons. So the extension of the soliton class of metrics can also include charge. The scalaron cloud can also be charged, could be charged. And the preceding comments show that solitons are indeed strange objects. They will probably continue to rediscover by eager, if irate workers, but what is really needed is a better understanding of the physics and perhaps an observational proof of their existence. So we are at the conclusion. You saw these stars with numbers, and I recall them. The focus should be put on interaction between electromagnetism and gravity. Movement with changing level of gravitational potential causes upwards. Kinetic energy is incorporated into the gravity field and cannot be localized any longer. And gravitational potential downwards. Non-localized gravity field energy is accumulated into kinetic mass. Space of the universe gains gravitational potential energy over time. Thus, a moving mass loses kinetic energy, called Hubble drag. The 4D space is a resizable hypersurface in 5D. Shrunken space, sunken gravitational potential energy, gets increased temperature, which was the red area, opposite to decreasing microwave background radiation. Variations in 5 dimensions cause a new force, which was the green area and could be lifting. Fluttering space causes disruption of material. Can space break into different separate 4D membranes? It's a question, green area. Higher separated 4D brane, which was violet, may be shoved above the lower separated 4 brane, which was red. Or, with RF frequency, a wobbling causes a double layer, both resulting in two different bodies sharing the same location in 4D. The gravity constant, the scaling factor between mass energy and cross curvature may vary. It could also be a source for a force. Electromagnetic field energy may dispense energy to the scalar field, pumping energy into the room. Static electric field without localizable field energy. No field energy without magnetic field. So under pure electrostatic conditions, there might be no effect. 4D brane plus charge mass vector form a pelt or carpet with spirals. Pyramid is a symbol for 5D force. A soliton consists of radiation, but does not contain any photons, but scalarons or gravitons. Solitons may be charged. So this was the physics, which could be puzzle parts of the physics which could be behind the Hutchison effect. It's very difficult to speak about it, and I hope you grabbed what I was telling, and yes, we may discuss about this topic. So, thank you.
Wonderful. Detlef, thank you, sir. Thank you. Let me do this. I want to stop your screen sharing.
Yep.
And I want to put this bad boy on gallery mode. We have 65 people with us today. This is kind of a full house for APEC. So everyone, please put your hands together and applaud Mr. Detlef Hoyer. Sir, that was a wonderful and in-depth presentation. Thank you so much for joining us, and thank you for presenting today.